This is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about problems on t-distribution for single mean and t-distribution for difference of means. So, test of hypothesis for small samples. These are all test of hypothesis for small samples. There are three types of tests in test of hypothesis for small samples. First one is t-distribution, second one is f-distribution, and third one is chi-square distribution. So, in t-distribution, there are two types of t-tests are there. So, first one is t-test or t-distribution for single mean, and the second one is t-distribution for difference of means. First one, t-distribution for single mean. Consider a sample of size small n with mean x bar and variance s square is taken from the population having mean mu and sigma square variance. Then the test statistic is given by t equal to x bar minus mu by s by root n, where s square equal to 1 by n minus 1 into summation I equal to 1 to n xi minus x bar whole square. So this is our main formula. So this formula is for t-distribution or t-test for single mean. And here s square equal to 1 by n minus 1 into summation I equal to 1 to n xi minus x bar whole square. We can choose the tabulated value t alpha by 2 at nu equal to n minus 1 degrees of freedom. Conclusion. So if modulus of t less than t alpha by 2, then we accept null hypothesis. If modulus of t greater than t alpha by 2, then we reject null hypothesis. First problem. The producer of gutka claims that the nicotine content in his gutka on the average is 1.83 mg. Can this claim be accepted if a random sample of 8 gutkas of this type have the nicotine content of 2.0, 1.7, 2.1, 1.9, 2.2, 2.1, 2.0, 1.6 mg. So given n equal to 1, 2, 3, 4, 5, 6, 7, 8. So n equal to 8 and mu equal to 1.83. Mu equal to 1.83 mg. Because here they have mentioned no. So that is mu value, average value, that is nothing but mu. That is mu equal to 1.83. Null hypothesis. So coming to the null hypothesis is denoted with H naught. So that is equal to mu equal to 1.83. Okay. So in the single mean, we have to take population mean. So population mean is denoted with mu and the sample mean is denoted with x bar. So population variance is denoted with x sigma square and the sample variance is denoted with s square. So population standard deviation is denoted with sigma, sample standard deviation is denoted with s. Okay. So coming to the problem, first step 1 is null hypothesis. Null hypothesis is denoted with H naught. In this H naught, mu equal to 1.83. Mu value is 1.83. Alternative hypothesis, that is denoted with H1. Alternative hypothesis is nothing but opposite to the null hypothesis. That means if mu equal to 1.83 means mu not equal to 1.83. Level of significance. So here the level of significance alpha equal to 0.05. So in the question they have not mentioned, we have to assume that the alpha value is here 0.05. So in t distribution for single mean, we need to take t alpha by 2 for n minus 1 degrees of freedom. Okay. So here alpha value is 0.05. So that's why we need to take 0.05 divided by 2 for n value is 8 minus 1 degrees of freedom. So t of 0.025 for 8 minus 1, that is nothing but 7 degrees of freedom is So in T distribution table, so we have to take these values from the table. In T distribution table, we have, so these are all alpha values. Okay, so these are all new values. So this is nothing but new equal to n minus 1 degrees of freedom. So these are all new values. So here we have 0, 1, 2, 3 and so on. Here we have 7 and somewhere here we have 0.025. So this value is 1.895. This value is 1.895. So we have to take this value from the distribution table, T distribution table, students T distribution table. Okay, so from that table we can find the value of 1.895. So that means T alpha by 2 at nu equal to n minus 1 degrees of freedom. Here nu value is 7 and alpha value is 0.025. Okay, so from that we can find 1.895. And for test statistic, the test statistic T equal to x bar minus mu by s by root n. So, but we don't know x bar value. So, from that and s value also we don't know. So, that's why here they have given that xi values, right? So, these are all xi values. So, we need to find s and the x bar. Okay, s and x bar. Okay. For that, we need to find the table. So these are all xi values. Xi values are these xi values are 2.0, 1.7, 2.1, 1.9, 2.2, 2.1, 2.0, 16. Okay. So summation xi is this one. Summation of xi by n is nothing but x bar. So x bar equal to summation xi by n. So summation of all these values 2.0 plus 1.7 plus 2.1 and so on up to 1.6 divided by n. N value is 1, 2, 3, 4, 5, 6, 7, 8. N value is 8. That is equal to, we will get 1.95. So that means here x bar value is 1.95. Okay. So x minus x bar 2.0 minus 1.95. We will get 0.05. 1.7 minus 1.95, that is minus 0.25. 2.1 minus 1.95, 0.15. So 1.9 minus 0.95, sorry, 1.9 minus 1.95, we will get minus 0.05. So 2.2 minus 1.95, we will get 0.25. So 2.1 minus 1.15, we will get 0.15. So 2.0 minus 1.95, then we will get 0.05. So 1.6 minus 1.95, we will get minus 0.35. Okay. So summation, so this is x minus x bar whole square. So this one whole square is this one. So minus 0.25 whole square is 0.0625. So like that, this whole square is these values. Okay. So summation of xi minus x bar whole square we need. So that is that value we can find. Okay, so after adding 0.025 plus this one plus 0.0025 plus 0.1225, then we will get summation of that value. Okay, so x bar is nothing but a summation xi by n, that means 15.6 divided by 8, that is equal to 1.95, and s square, for s square we have formula, that is summation xi minus x bar whole square divided by n minus 1. So summation xi minus x bar whole square, that is 0.3 divided by 7, that is equal to some value. So from that we will get s square equal to that value and s equal to under root of this value. Then s equal to, we will get 0.21. So from the test statistic T equal to x bar minus mu by s by root n. No. So from that in that formula we can substitute x bar value. So x bar value is 1.95 and mu value in the question they have mentioned mu value, that is this is mu value is 1.83 divided by s value. So s value is 0.21 divided by n is 8. So mod t equal to So here this t value is 1.62 and mod t equal to 1.62. Conclusion. Mod t is 1.62 and t alpha by 2 value is 1.895. 1.895. So 1.62 is less than 1.895. So therefore we accept the null hypothesis. So this is our exercise problem for t distribution for different single mean. So the lifetime of electric bulbs for a random sample of 10 from a large consignment gave the following data. So item is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and life in 1000 hours is 1.2, 4.6, 3.9, 4.1, 5.2, 3.8, 3.9, 4.3, 4.4, 5.6. Okay. So we have to use t-test for single mean. Next one is t-distribution for difference of means. Consider a population with mean mu and variance sigma square. If we choose two small samples from the population of sizes n1, n2 and with means x1 bar and x2 bar. These are sample means and sample sizes and sample variances are s1 square and s2 square. Then the test statistic t is given by t equal to x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. Where s square equal to, we have a formula that is 1 by n1 plus n2 minus 2 into summation I equal to 1 to n xi minus x1 bar whole square plus summation I equal to 1 to n xi minus x2 bar whole square. Or s square equal to 1 by n1 plus n2 minus 2 into n1 s1 square plus n2 s2 square. Note, the value of t alpha by 2 or the tabulated value can be chosen from the table at nu equal to n1 plus n2 minus 2 degrees of freedom. Nu equal to n1 plus n2 minus 2 degrees of freedom. First problem. Two independent samples of 8 and 7 items respectively had the following values. Sample 1, 11, 11, 13, 11, 15, 9, 12, 14. Sample 2, 9, 11, 10, 13, 9, 8, 10. Is the difference between the means of samples significant? Given. So, n1 value is 1, 2. So, n1, this is n1 and this is n2. n1 is 8 and n2 is 7. So, we need to find the difference between the means. That means t equal to x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. We need to follow this this formula. Okay. So, here we need to find x1 bar and x2 bar. So, x1 bar equal to, so we have x1 bar equal to summation xi by n. Summation xi means these are all xi values and these are all x1 x1 x2. Okay, so these are all xi values and these are also xi values. Okay, so here the values are n equal to 8, n1 equal to 8 and here n2 equal to 8. So x1 bar equal to summation xi by n. Summation of xi means 11 plus 11 plus so 11 plus 11 plus 13 plus 11 plus 15 plus 9 plus 12 plus 14 divided by n. N is nothing but 8. Okay. So that is equal to 12. So x1 bar equal to 12 and x2 bar is also same, summation xi by n. So here summation xi values are 9 plus 11 plus 10 plus 13 plus 9 plus 8 plus 10. Okay, 9 plus 11 plus 10 plus 13 plus 9 plus 8 plus 10 divided by 7, that is equal to 10. So next we need to find summation xi minus x1 bar whole square. So that is xi values are these, right? So 11 minus this 12 whole square. Next 11 minus 12 whole square, 13 minus 12 whole square, 15 minus 12 whole square, 9 minus 12 whole square, 12 minus 12 whole square, 14 minus 12 whole square. So after simplification, we will get 26. Like that, summation I equal to 1 to n xi minus x2 bar whole square. So this is xi minus x1 bar whole square, and this is summation xi minus x2 bar whole square is xi values are here 9, 11, 10, 13, 9, 8, 10, right? So 9 minus 10 whole square, 11 minus 10 whole square, 10 minus 10 whole square, 13 minus 10 whole square, plus, here we have summation, no? We need to put plus 9 minus 10 whole square, plus 8 minus 10 whole square, plus 10 minus 10 whole square. So after simplification, we will get 60. Okay, so S1 square equal to, we have formula that is 1 by N1 plus N2 minus 2 equal to summation I equal to 1 to N xi minus x1 bar whole square plus summation I equal to 1 to N xi minus x2 bar whole square. So that is equal to 1 by N1 8 plus N2 7 minus 2 summation xi minus x1 bar whole square is 26 and summation xi minus x2 bar whole square is 16. So 26 plus 16. Okay, so from that we will get S equal to, S is nothing but under root of variance. So S equal to 3.23. So S equal to under root of S square, that is 3.23. So now coming to the step 1. In the step 1 we have to take null hypothesis. Null hypothesis is always denoted with H naught. Null hypothesis is nothing but H naught, denoted with H naught. So in the H naught we are taking the sample means. There is no difference between the sample means. x1 bar equal to x2 bars. That is nothing but there is no difference between the sample means. Sample means. Next, alternative hypothesis. Alternative hypothesis is denoted with H1. Alternative hypothesis is denoted with H1 and alternative hypothesis is nothing but opposite to the null hypothesis. That means there is a difference between, the sample means. That means x1 bar equal to, x1 bar not equal to x2 bar. x1 bar not equal to x2 bar. Now coming to the level of significance. So here we have to assume that they have not given alpha value, right? So we have to assume that alpha value, the alpha equal to 0.05. In t distribution for difference of means, we need to take t alpha by 2 at nu equal to n1 plus n2 minus 2 degrees of freedom. So alpha is 0.05, no? So 0.05 divided by 2 for nu equal to n1 value is 8 plus 7 minus 2. That is nothing but 13 degrees of freedom. Okay. So T 0.05, 0.025 for 13 degrees of freedom is 2.16. So we have to take this value from the T distribution table. T distribution table. Okay. So in the T distribution table, these are all alpha values. And these are all new values. Okay, so 0, 1, 2, 3 and so on up to here we have some 13 is there. Okay, so here this is 0.05, 0.025 is there. So in 0.025, in 13 we have to take this value. So this value is 2.16. Okay, so in the table we have to choose this value, that is 2.16. Next one is test statistic. Fourth step is, our fourth step is test statistic. In the test statistic, t equal to x1 bar minus x2 bar divided by s into and the root of 1 by n1 plus 1 by n2. So x1 bar is already we have find, that is 12 and x2 bar is 10. So 12 minus 10 divided by, what is s value? S value is 3.23, sorry. This is 3.23 divided by under root of 1 by 8 plus 1 by 7. So that will be, after simplification, we will get t equal to 2.15. But we need modulus of t. So therefore, modulus of t equal to also same 2.15. 2.15. So this is 2.15 and t alpha by 2 is also t alpha by 2 is 0.025, right? So that is 0.025 value 2.16. So this is 2.16. 2.16. So this is 2.15 and this is 2.16. 2.15 is less than 2.16. So therefore, we accept the null hypothesis. Therefore, we accept the null hypothesis. That means there is no difference between the sample means. Okay. So that means the given statement is correct statement. Okay. So therefore, there is no difference between the sample means. So this is our required solution. So this is our exercise problem based on T distribution for difference of means. Samples of students were drawn from 2 universities and from their weights in kilograms, mean and standard deviations are calculated and shown below. Make a large sample test to test the significance difference between the means. So University A 55 and the mean is 50. In University A mean is 55 and University B mean is 57. University A mean and standard deviation is 10 and in University B the standard deviation is 15. In University A sample size is 10 and in University B the sample size is 20. Okay, so based on T distribution for difference of means, T distribution for difference of means, we can find this problem. Okay, so the formula is T equal to x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. So this is our formula. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.